Hey everyone, welcome to this explainer. Today we're diving into a really fascinating record of observation by Tommy Yoshida. Now, right off the bat, I want to be clear, we are not here to pass judgment on AI itself or hand down some grand final conclusion. Instead, we're looking at unfinished thoughts and pending questions about how AI, technology, and human judgment are colliding right now in this crazy transitionary phase. It's a massive shift, and we're just here to observe exactly how it's playing out in the real world.
Okay, so let's get into it. As AI explodes globally and these massive data centers pop up literally everywhere, we usually focus on their insane electricity usage, right? And, fair enough, it's a huge issue. But what constantly gets overlooked, like almost entirely ignored, is the massive amount of thermal energy these servers vent straight out into the atmosphere. So the big question is, what actually happens to all that heat? Well, to answer that, we have to look at the physical reality of the cloud. Because AI isn't just happening in some magical, weightless digital void. It's incredibly physical. It demands huge tracts of land, tons of water, and endless electricity. And because of all that processing power and the heavy cooling it requires, it kicks out a continuous byproduct of heat that, honestly, we mostly just treat as garbage right now. But reusing this heat isn't just some sci-fi pipe dream. Take a look at Odense, Denmark. This is a brilliant example of what's actually possible. Out there, data center heat is captured using heat pumps and fed right into a local heating network. They are recapturing 100,000 megawatt hours of energy. To put that into perspective, that is enough to warm roughly 7,000 households every single year purely from server exhaust. Pretty incredible, right?
And locally, here in Japan, that same momentum is really starting to build. The Ministry of Economy, Trade and Industry is actively looking into advanced immersion cooling to handle AI's sheer power hunger. Meanwhile, NTT Facilities is pitching totally new data center models that don't just vent heat into the sky, but actually share it with nearby homes, offices, and greenhouses. The whole conversation is finally shifting from how do we get rid of this heat to how can we actually use it?
Section 1. The Kagawa Prefecture Case Study, Designing Local Connections. So let's look at Kagawa Prefecture. It's super unique because its compact size means urban areas, farmland, and public facilities are all packed really close together, making it an absolute perfect testbed for a local energy loop. Let's start with greenhouse horticulture. Farmers here grow crops that need really precise temperature control all year. We're talking intensive cooling in the summer and, crucially, heating in the winter to keep everything alive. Now, here's where the practical application gets super interesting. Sure, server exhaust isn't exactly boiling hot. It can't spin a massive turbine to generate electricity, but if you use heat exchangers, it becomes this perfect supplementary heat source. It's an amazing way to slash winter fuel costs for local farms. I mean, think about it. You are literally using the waste heat from a computer crunching data to help grow a tomato.
Next up in the local ecosystem, we've got bathing facilities, hot springs, and lodgings. If you've ever been to one of these spots, you know they need a massive, never-ending supply of hot water. Every single day. The energy demand is just relentless.
Now, trying to boil that huge volume of water directly with server exhaust just wouldn't work. But you can use that lower-grade data center heat to preheat the water supply before it even hits the boiler. Just by bumping up that baseline temperature first, you are drastically cutting the facility's overall fuel and electricity use. It's such a simple yet elegant solution.
Then there is the civic infrastructure. When you pipe this exhaust heat into public facilities, like schools, libraries, government buildings, and heated pools, it does way more than just save the city money. It actually physically connects this invisible AI infrastructure right to the daily lives of the people living there. Suddenly, the cloud isn't just an abstract idea. It's literally what is keeping the neighborhood library warm in the middle of January. But we do need to tread carefully here. When we start talking about welfare facilities, like elderly care homes or disability support centers, we absolutely cannot just treat them as convenient dumping grounds for our excess heat. As the quote here reminds us, welfare facilities are not just heat receptacles.
The vital thing to remember is that these populations are incredibly sensitive to environmental changes. So using this heat means designing systems that are absolutely fail-proof. We're talking total thermal stability, incredibly strict safety protocols, and ironclad disaster backups. You can't have someone in a care facility freezing just because a server needs to go offline for an hour, right? The human element has to come first, always. Section 2. Existing versus future facilities. The paradigm shift. Grounding this back in Kagawa's current reality, there are already facilities up and running, like an AI data center in Takamatsu and another in an old abandoned school in Ayagawa town.
But retrofitting these existing setups is a massive headache. Piping heat after the building is already there is incredibly tough. You've got long distances causing heat loss, mismatched cooling systems, and sky-high infrastructure costs. Because of this, we really have to test out modest, highly localized uses first, like that basic water preheating we talked about, without banking on total success right away.
And that brings us to a huge paradigm shift in how we have to design infrastructure from here on out. It's the stark contrast between the absolute struggle of retrofitting old buildings with small heat-sharing hacks versus the massive, untapped potential of purpose-built, co-located designs for our future facilities.
For any new facility moving forward, the answer is co-location right from day one. Instead of dropping a massive data center out in the middle of nowhere and then scratching our heads later wondering what to do with the waste heat, we need to design them right next to the greenhouses, the bathhouses, or the public buildings that actually need that warmth from the very get-go. This basically rewrites the whole checklist for community AI infrastructure. It's not just about hooking up power grids and massive cooling fans anymore. It forces us to ask, who exactly is going to use this heat? Are the pipes short enough so we don't lose the warmth? Is there actually a year-round demand for it? And do we have safe backups in place? It really makes us ask how this new building is going to integrate into the actual physical survival and comfort of the neighborhood around it. Now, Kagawa might not have the dense, heavy demand of a massive metropolis like Tokyo, but that's actually a huge advantage. Its smaller scale lets us run focused regional models to really test these local energy loops. We can hook up single data centers to nearby farms or local pools without needing to build multi-billion-dollar citywide heating grids. It is literally the perfect laboratory for this kind of future. As Tommy Yoshida so beautifully puts it, AI is not only something that happens on a screen, it is profoundly physical. It relies on land, water, cooling, and community. And honestly, it is high time we start treating it as a local, physical utility rather than just some abstract, untouchable cloud in the sky. So, I want to leave you with a pending question to chew on as we navigate this crazy transition. As we build out the vast intelligence of our future, can we design ways for its physical warmth to responsibly, carefully, and safely return to human life? Think about that the next time you fire up an AI tool. All that heat it generates has to go somewhere, so why not use it to keep us warm? Thanks so much for joining me on this explainer. Keep asking questions, and I'll see you next time.